Hello everyone. In this session, we are going to see about the introduction of programmable logic controllers (PLC). So PLC, it was invented in 1968 as a substitute for hardwired relay panels. These relays have been used in different circuits for controlling. This PLC is an electronic apparatus which has got some memory in which we can save different programs. So these programs will result in controlling the required equipments. This program memory is an internal storage for storing the instructions. With these instructions, PLCs can perform different functions such as logical sequencing, timing, counting, most importantly, arithmetic to control through digital or analog input-output modules. So this logic control is used in various types of machines or processes. In industrial automation, this control is very much useful. PLC is very much used in industrial automation for controlling conveyors, door opening, closing, and different handlings. So this PLC architecture is very simple and similar to a computer. It has a input module, processing module, and an output module. Input module, it can receive input from a switch. It could be an analog input. It could be a pressure switch. In most cases, we can see PLC getting input from different types of sensors as well. So from this input module, the data is fed into the central processing unit. Central processing unit is where you have the memory, where the instructions are stored. Here, all of us have to remember one thing. PLC needs a device to externally program the instructions and then store it in the memory. For this, a desktop is very useful. For this, a desktop is very useful. Based on the instructions that is stored in the memory, the output instructions are given. So this output module are directly connected to the actuators or to controllers in terms of if it was to be a control of a motor. So here you can see a motor, a pump, or other output devices or output loads are connected here in the output module of the PLC. So all the modules are given a common power supply. This is the architecture of the PLC. So same architecture we are looking in a schematic way. So programs are written in a PC or desktop stored in the memory unit. It has got many registers. In the later sessions we will see about these registers in the PLC. It receives input and look into the logic, and based on the logic the control unit is there. A motor is being controlled through a control unit. So all of us have to remember this part. We need a device to program the PLC. We cannot directly, it's not easy to directly program the PLC. You need an external programming device. Where this automation we are using PLC. So first we have to understand there are various levels in a PLC. So at the very lowest level you have the process layer where the actuators are working. So these actuators are controlled in a layer where PLCs are employed, and on top of that you have SCADA layer, and then there is data exchange layer. In this unit we are bothered about only the PLCs. PLC play a vital role in controlling the actuators. By controlling the actuators, PLCs are used to control the processes taking place in any industry. So in the field level, sensors and actuators, there will be point-to-point connection, and all these connections are controlled by the PLC. PLC will have the logic instructions stored in the memory through an external device. So there are different parts of this PLC that you can actually see. So very basic is the power supply module, and then there is input output controller and connection cables. Next to that you have this CPU module, which is having the memory space register for storing the instructions. Then you have analog input module, you have analog output module, likewise you have communication module, output input module, and then you have also have dummy slots for increasing the capacity of the PLC. So different advantages are there when we are using a PLC. Where few are given here. Few are given here. Programmable controller has eliminated much of the hand wiring associated with conventional relay control circuit. You might have come across relay circuits. It is a very difficult circuit to replicate. The program logic controllers are mainly brought into the field to eliminate this relay circuit. Once a program is written and it is compiled, we say in programming, or we test it, we can directly download it to the PLCs, and the same program can be downloaded to other PLCs in the control level of automation. PLCs, they are brought into the picture to replace relay control logic. Now it is not only doing this replacement process, it is also doing various tasks like counting, calculating, comparing, and processing of analog signals. Cost saving has been very significant after the application of PLC, because a small device has replaced the entire relay control here, especially for, so now this relay control is being completely replaced in electronic control. Only in power applications relays are still in place. Other important versatility of PLC is it can communicate with other computers or other controllers easily. By networking, we can easily establish this connection. They can perform many number of tasks. Once this is connected in the network, PLC can become a supervisor and can control the other lines. It can gather data from the lower level actuators and other units. It can monitor device and process parameters, and all this data can be downloaded from the PLC to a desktop. Now these PLCs are not like some offline devices, they are employed online. They can operate in real time, which means whenever there is an event happening, it can immediately take a response call on it, and it also records the happening, so that later the engineer or the associated person can do a detailed analysis of what has happened and do troubleshooting there also. And PLCs, they have real-time diagnostic systems. You just like plug and play. In PLCs, you plug this thing and you can download all the data from the real time, and it is very easy to troubleshoot. And it is also having override function, so you can correct the software at any time. Even the hardware problems are very easy to troubleshoot with the PLC. This is the main reason PLC has become one of the most important and inevitable part of industrial automation. In further classes, we will study in detail about the PLC. Thank you.